Download this code from codegive.com, link in the description below. Understanding logical functions and implicit conversions when comparing int32 and int64 in C. This tutorial delves into the intricacies of using logical functions, like equality, inequality, greater than, less than, etc., when comparing int32 and int64 data types in C. We'll explore the potential pitfalls caused by implicit conversions and how to avoid unexpected behavior. 1. Data types, int32 and int64, a quick recap. *int32, system.int32 represents a 32-bit signed integer. Its value range is from -2,147,483,648 to 2,147,483,647. *int64, system.int64 represents a 64-bit signed integer. Its value range is from -9,223,372,036,854,775,808 to 9,223,372,036,854,775,807. The key difference lies in the number of bits used to store the value, which directly impacts the maximum and minimum values the type can represent. int64 offers a significantly larger range than int32. 2. Implicit conversions, the potential source of confusion. C supports implicit conversions between certain data types. This means the compiler can automatically convert a value from one type to another without requiring explicit casting, if the conversion is considered safe, i.e., no data loss is expected. In the case of int32 and int64, an implicit conversion exists from int32 to int64. This is because any value that can be represented by an int32 can also be perfectly represented by an int64. No data is lost during this conversion. However, the reverse conversion, from int64 to int32, requires an explicit cast. This is because an int64 value might fall outside the range of int32, potentially leading to data loss or overflow. 3. Logical functions, the comparison operators. C provides a set of logical, or comparison, operators to compare values. These operators return a bool value, true or false, based on the result of the comparison. *= equality checks if two values are equal. *= inequality checks if two values are not equal. * greater than checks if the left-hand operand is greater than the right-hand operand. * less than checks if the left-hand operand is less than the right-hand operand. * greater than or equal to checks if the left-hand operand is greater than or equal to the right-hand operand. * less than or equal to checks if the left-hand operand is less than or equal to the right-hand operand. 4. How comparisons work with int32 and int64. When you compare an int32 value with an int64 value using these logical operators, the C compiler performs the following steps. 1. Implicit conversion *. The int32 value is implicitly converted to an int64 value. This creates a temporary int64 representation of the int32 value. 2. Comparison *. The comparison is performed between the two int64 values. 3. Result *. The logical operator returns a bool value based on the comparison result. 5. Code examples, demonstrating the behavior. Explanation of the code ***. The code demonstrates the use of various comparison operators with int32 and int64 values. In all cases where comparisons are made, the int32 is implicitly converted to int64 before the comparison takes place. Asterisk. The final section highlights the risk of overflow if you attempt to convert a large int64 value to int32 without proper checks. Using checked keyword will trigger an overflow exception if the value is out of the int32 range. 6. Potential issues and best practices. While implicit conversion simplifies comparisons, there are a few things to keep in mind. Asterisk. Clarity. Asterisk. Although implicit conversion is automatic, explicitly casting for clarity can improve code readability, especially in complex scenarios. Asterisk. Overflow. Asterisk. Be very careful when converting from int64 to int32, especially if the int64 value originates from an external source, example user input, file data, network stream. Always include checks to prevent potential overflow and data loss. You can use the checked keyword or explicit range validation. 7. Overflow prevention techniques. Here are a few techniques to prevent overflow when converting from int64 to int32. Asterisk. Checked keyword. Asterisk. The checked keyword instructs the compiler to generate code that throws an overflow exception if an arithmetic operation, like casting, results in a value outside the target type's range. Asterisk. Range validation. Asterisk. Before casting, check if the int64 value falls within the int32 range using int32.min value and int32.max value. Asterisk. Math.clamp, C11 and later. This method allows you to clamp the int64 value to the int32 range. If the original value is outside the range, it will be set to the nearest boundary value, minimum or maximum. Note that this still results in data loss, but it prevents exceptions. 8. Alternatives to direct casting when overflow is possible. If you cannot guarantee the int64 value will always fit within the int32 range and cannot afford to lose information, consider these alternatives. Asterisk. Keep the int64. Asterisk. If possible, simply continue working with the int64 data type. Adjust your code accordingly to handle the larger values. Asterisk. Use a different data type. Asterisk. If int64 isn't suitable, consider using decimal, which offers even greater precision, but is typically slower. Asterisk. Error handling. Asterisk. Instead of casting, implement a robust error handling mechanism to gracefully deal with values that are out of range. This might involve logging the error, displaying a message to the user, or taking alternative actions. 9. Summary. Asterisk. When comparing int32 and int64 in C, the int32 value is automatically converted to int64 for the comparison. This usually works smoothly. Asterisk. Be extremely cautious when converting from int64 to int32. Asterisk. Employ checked blocks or range validation to prevent unexpected overflows and data loss. Asterisk. Choose the appropriate data type and conversion strategy based on your application's requirements and the potential for values outside the int32 range. Asterisk. Prioritize clarity in your code by explicitly casting where appropriate, even if implicit conversions are available. This can significantly enhance maintainability. By understanding these nuances, you can effectively use logical functions to compare int32 and int64 values in C and write robust, reliable code. Remember to always prioritize data integrity and handle potential overflow scenarios gracefully.